Hi everyone, my name is David Townsend. I'm a partner sales engineer here at Juniper Networks, and it's my absolute pleasure to take you through this third installment of these series, which is focusing on our cloud-ready data center solution. And the solution within that is, of course, Apstra. And during this third installment, we're going to be talking and demonstrating the day one operations of the Apstra solution for data centers and showing you how agile, quick and powerful this solution actually is. But as I've always said, if you have any questions or queries, comments, etc., if you could please email those to the sales team at sales@kubus.com, and they'll be more than happy to respond to any questions, queries or comments that you may have. So let's begin. So I've shown this slide on every single one of these sessions that I've done, so it's really more of a refresher. Now, when we talk about the Juniper portfolio, we really like to show for the AI-driven enterprise, we really like to show this slide where right at the top of this pyramid, this is what we call our true north, is our experience first networking. So whether we're talking about Mist within our AI-driven enterprise for cloud-based artificial intelligence microservice solution for wired, wireless, and SD-WAN, and even security solutions, or the automated WAN using our session smart routers using tunnelless technology, or for the topic of this installments for these sessions, our cloud-ready data center and Apstra, we're always talking about experience. It's not just about the experience of the network. We're actually talking about the experience of the users over their network. And that is really our Juniper's true north. And all of this is, of course, underpinned by our zero trust policy, our connected security. So it doesn't matter if we talk about data centers with the QFXs or automated WAN with our session smart routers and SRX gateways, or even wireless APs, EX switches, firewalls in the AI-driven enterprise I Mist. Everything is connected together from the front hall, the access, all the way to the core. So focusing more on Apstra now, I'd really like to just show this slide. And these are all challenges which really lead networks team to have too much to do. So from a monitoring tool, proliferation, number of devices, components, this is really a needle in a haystack challenge to pinpoint a issue or a number of issues. Cross-functional finger pointing, network teams on the defense, and they must prove their innocence. The MTTR, the mean time to resolution or even repair, the length of time to roll back a change when issues arise once you've identified them, of course. Changing reviews, it's an onerous task, that delays new services and can even delay important fixes. And of course, every vendor has got a number of COIs commands, so too many COI touch points for one change that can add to complexity. Lack of visibility for grave failures to get ahead of device issues, security patches, multi-vendor setups creates challenges in the setup, visibility, and the trouble to identify issues in the first place. And then, of course, right at the end, you've got the great resignation of really people having all these great networking skills, and it creates really a scarcity, which is impacting the performance of the network, the data center itself. So why is all of this important? Well, all of that is challenges, but it all really creates quite a complex environment, and complexity is likely to be a key challenge in most data centers, as they would have evolved over time to keep pace with new innovations and applications, platforms, performance needs, cloud interoperability, scalability, etc., etc. And when you look at public cloud, and when they want public cloud consumption, the feel, but getting deployments ready, being designed and tested, deployed, all of that takes up way too much time. So if you look at it from design templates, manual tasks, device misconfigurations, monotonous changes, often not kept documented, let alone validated or compliant, this causes significant delays and performance issues. And questions like, did it work? How many approaches did we try? How did we measure them? Did we put things back the way we found them? Are really all typical types of questions you find. And the truth is that customers, they don't know what they are comprehensively have in measurable capability as an impact to the business. Number one, priority. And because of that, they don't feel like they can communicate or collaborate. Priority two, with an emphasis on IT archaeology for consumption. Now, Apstra recognises that the challenges are residents in any deployment, but can deliberately generate a fast fail to a fast success in any operational sense, faster than any of our competitors out there, while measuring the impact itself. And the data center architectures and management of today keep teaching us the same tired lessons of single device misconfiguration, monotonous changes without measurement, compliance, validation, and human process latency. Now, while learning once is the nature of networks driven by application needs, it is Apstra that prevents learning the same thing twice with its analytics, compliance management, and intent time voyager. So with Apstra in summary, the question is no longer did it work, but was this the right approach? How many approaches did we try? How did we measure them? Did we put things back the way we found them? And what best reflects our current vision and strategy for the security of the data center network? Apstra really solves all of those questions by providing this unified single pane of glass intent-based solution, which gives you the analytics, the deployment, etc., that you need to ensure that your data center is operating the way it should be and delivering the outcomes that you actually need from both a business and operational perspective. So the last session we concentrated on day zero, i.e. designing. So we designed the network from an Apstra point of view. We designed the resources, the agents, the racks, the templates. We designed the data center itself. And during this session, we're going to be building and deploying that data center, i.e. the day one operations itself. So enough talk from me. Let's carry on with the demonstration itself. So let me just minimize this slide. So let me minimize this a little bit more. So what you can see here, and this is just a refresher, I have the data center itself here. We've got our leaves, we've got our spines. It's a very simple setup, a number of tenants here, servers, web applications, whatever it may be. These are just management IPs, but here are the network tenants themselves and our resources pool. And when I click on the Juniper Apstra, we're going to lose this display, and that's why I've got the notepad on here so you can see what the tenant 1, 2, and 3 VLANs, subnets, and VNIs actually are. So let's begin with the day one operations. Now, as you might recall, if I actually go into design and templates, you can actually see that from the last session, we created this data center template where we had 3 spines, a number of racks, and connected to a top of rack, which would be our top of rack leaf, and connected to each leaf was one single server, which, as you can see, really replicates this design model here. That was us designing our data center. But now we wanted to deploy it. We want to take that template and deploy it. And to do that, we have to create a blueprint, which allows you to have a number of blueprints for a number of different data centers from one single Apstra solution. So let's just call this data center 1, just for example, and here you can say you can filter on those templates which have those spines as top of rack leaves, everything that we really designed in the last session. And right at the top you can see my data center template, which I just showed, and if I just scroll down you can actually see the links and spines, leaves, etc. here. So I'm just going to create this now, and you can see it's creating the blueprint, and once it's actually scaffolded all the information and configuration into that blueprint, we're then going to start deploying the configuration itself. So you can see on data center 1, it's three spines, 6 leaves, 6 generic systems. So there's nothing really showing in terms of anomalies or root causes, and that's purely because we haven't deployed it yet. So let's just click on data center 1. And as a quick review of what you're seeing, so this is the user interface. So the dashboard is where you would see key metrics and alarms and events, but obviously it hasn't been deployed yet, so there's nothing to see. Your analytics, where you would see specific analytics and anomalies via intent-based probes. But again, this isn't deployed, so there's nothing to see. Uncommitted is where you'd commit specific configurations. And this is really important when it comes to the time voyager. So if you do create a configuration and you commit it, if it was the wrong configuration, you can actually revert back in time as such, revert back to the previous configuration via the revert button here. But again, we haven't really deployed anything, so there's nothing to commit just yet. So the way that this works from the Apstra user interface is first we go into stage. We want to stage this deployment, and we have these number of different tabs. Most of these I'm going to be going through, but not all of them. From a physical perspective, this sub tab here, we really want to state, well, what are the ASN numbers for the spines, the leaves, the loopbacks for the spines, the loopbacks for the leaves, and the fabric itself. And this is coming back to the resource pool. So if I just click on VNI pools, in the last session, you could see I created layer 3 VNIs, and I even created IP pools for the fabric and for the loopbacks. And that's where we're going to be using those resources during this configuration. So if I actually just click on this right hand side here and select ASN spines, update assignments, well, I just want this to come out of my ASN pool that I've configured. I don't really care what ASN number goes onto each spine. I just want Apstra to actually handle that configuration for me. And now you can see all of those 3 spines have gone green. Obviously green is a good indication that something is right. Bad is an indication that actually something's not right, or some kind of action needs taken here. And it's the same concept for the ASN leads. I click update assignments, and I want each lead to be assigned automatically from Apstra and ASN from the ASN pool I created. Save, done. And you can see those going green. And I just do the same for loopbacks for the spines. So update assignments, and on the next tab, one before, loopbacks, I went right by it. Loopback for the leaves. And you can have obviously different pools for these. You don't have to have them all coming out the same pool like I've got. I'm just doing that to keep things simple. So you can manage your network with more control, as in terms of resources and the fabric. Save that. So the fabric is the IP addresses that are going to be going on the interfaces themselves. And that's it. So that's really the first part is defining from a physical perspective what are the IP addresses and ASNs assigned to the spines and leaves. Now we have to go into device profiles. Now here's where we manage the interface maps. Just for recap, the interface map, because this is a abstraction of a spine 3 and spine 1, is an abstraction of your intent. I want spine 3. If I go back, if I want every spine with 6 interfaces with these speeds, etc., and these leaves with these interfaces pointed to the spines, pointed to the generic devices. That's my intent. The interface maps the logical device of the spine and leaves to a specific hardware vendor. Now for the data center spines, I now need to say, well, what interface map is spine 1, spine 2, spine 3? And obviously Apstra is a unique solution, the only one in the market where you can have the Apstra solution from Juniper actually controlling non-Juniper equipment. So for speed, I'm now going to say interface map spines. It's the only one that's selected here because all the spines don't have many ports, and Apstra knows that, well, actually for this switch where you've only got 6 ports, so you're running at 10 gig, all you really can have from a hardware device perspective is this interface map IM spine, which actually points to an Arista VOS. And again, refer back to the previous session to see more detail on that on the interface maps. But I just click update assignments, and that's it. So Apstra now knows, so spine 1, spine 2, spine 3. I have to use this COI, this IOS input to actually configure these spines, because these are Arista devices. And I need to do the same for the data center leaves. So I'm just going to do them all at the same time. Interface maps. Let's do it all at the same time. Interface maps. Sign selected. Update. And there we go. think I might have done something wrong on the data center spine, so let me come back. Yeah, so let's, I think I might have done it correctly. So let's do assign selected. There we go. Update assignments, and that's it. You can also assign the interface map for the generic devices, but this is optional. You don't have to do it, but I like to do it anyway, because Apstra is not going to be configuring and managing these devices. Update assignments, and there we go. So everything is looking great so far. The third part here is the assign system IDs. What is this? Every spine, leaf, super spine, etc., obviously not in this intent, in this design here, will have an agent, an on-box or off-box agent. Now, Apstra needs to know spine 1 has IP address xxx.1. Spine 2 has IP address, management IP address xxx.2, so on and so forth. So it knows in the configuration, not only is this Arista, this is Arista, this is Arista, or Cisco, Juniper, whoever it may be, but when it actually deploys the configuration that we're going to create and deploy here on Apstra, it knows where to push the configuration down to and obviously using which command line interface. So let's do assign system IDs. And this is important because if I now come back to the display, you can actually see the management IP. So this is via a management port. We don't configure the devices via data ports because if you lose connectivity to the data port, Apstra is essentially cut off. So we do it always via the management port. So you can see the IP addresses of spine 1, spine 2, spine 3, all the way down to leaf 6 is 101, 102, 103, 109 respectively. So let's just click on spine 1. Let's do check. And here we can actually see here is IP address 101, 102. So these are the off-box agents. Spine 3, 103, leaf 1, leaf 2, leaf 3, 5, 106, leaf 4, 7, 8, and lastly rack 6, leaf 1, 109, IP address 109 ending in. So here we want to deploy the actual configuration. Note you can do drain and deploy. I'm really going to go into this on the next installment, the day 2 operations. What is drain? I'm not going to steal my own thunder. I know that's probably a unique saying I like to use, but yeah, I'll be showing what drain is. It's really great feature for, shall we say, maintenance of your network, and it's done seamlessly. But let's update the assignments, and that's it. Really, from a physical perspective, what have we just done? First, we've really said, well, what are the ASNs? What are the loopback IP addresses? What is the fabric IP addresses? We've done that. We've also then defined, well, the interface maps. This is Arista, this is Arista, this is Arista. All of this is Arista, or it could be Cisco, or it could be Juniper. Obviously, preferably Juniper for us. And under devices, we then say, right, this is this management IP, this is this management IP, this is this management IP. And we do it for all those devices because, again, Apstra needs to know what device is not only what hardware vendor and what COI to use, but also what management IP address is assigned to what device, so it knows where in the configuration it actually sits and what configuration it does need and what it doesn't need. So let's now go on to virtual. So our virtual is where we actually allow, and you can see we've got these sub tabs here. We're just going to use virtual networks and routing zones. This is where we can actually create routing zones. So here I'm going to start configuring this information here. So I'm just going to call this tenant 1, spell it correctly. Tenant 1 routing zone. I'm not going to give any information here. I'm just going to give it a name. You can also create a VNI for layer 3, a VLAN ID, but typically that's not really used, and import specific route targets as well. But let's create another tenant 2 routing zone. And last, tenant 3 routing zone. Great. Okay, so you can see I've now got tenant 3 will appear in just a second, but we can now see Apstra. It's the solution is taken the configuration and done it for me. i.e. it's said, well, for this tenant, this tenant, just for the management side, I've got these VLANs here. You can also configure this by creating the routing zone. As I said, it's not typically used. People really like to use Apstra just to say, okay, well, for that management, just for the tenants, we'll just have what Apstra assigns, but you obviously have the control. No route targets and no VNIs. But if I now come back to virtual networks, here I'm going to say, well, what is tenant 1, tenant 2, tenant 3? So tenant 1, we're going to have a VXLAN. So here is tenant 1 virtual network, and this is going to tenant 1 routing zone. That's why I configured it first. And I want to have the same VLAN on all leads, VLAN 10. Within this subnet 192.168.10.0/24 and the gateway 192.168.10.1. So you know that if you know EVPN VXLAN, you know that that gateway is going to be assigned on each of the leaf devices as well, using edge routed and bridge to design. And here we're actually going to say, well, where do you want this configuration actually configured to? You know, in terms of racks. If I come back to the topology, we can actually see here we've got 2 hosts in tenant 1, 10.10, 10.11. So I need this going from server 1, rack 1 to server 4, rack 4 or leaf 4. So now I just say rack 1, leaf 1, rack 4, leaf 1. And that's it. It's now create another. This is VXLAN again. Tenant 2. Virtual network, going to tenant 2 routing zone. I want to have again the same VLAN 20, 192.168.20.0/24. Link then 192.168.20.1. And I know that this is going to go from rack 2 leaf 2 to rack 5 leaf 5. Like again, because 20.10, 20.11 both fall within this subnet here. So rack 2 leaf 1, rack 5 leaf 1, because there's only one leaf in each rack. So there could be more. And lastly, let's create the third tenant, VXLAN, tenant 3, virtual network. It's assigned to the routing zone, tenant 3 routing zone. VLAN ID 30. Again, that's why I put the information here. 192.168.30.0/24. And I know that this is going to go from rack 3 to rack 6. Great. And that's my virtual networks now created, but you can also see on the right hand side that Apstra's come back saying, well, this is great. These are assigned to a routing zone, but I don't know what VNI to use for a layer 2 perspective. I don't know what VTEPs to use from a layer 2 perspective. So let's go to VNI virtual networks first, and let's actually update the assignments for the virtual network identifier. So here I've actually said, well, I want you to use the pool here out of layer 3 VNIs. So I'll just say, yep, I want you to use these specific pools here. Let's update the assignments. And down here, I want to update the IPs. Now, again, you can have a particular IP address pool in your resources. So you can create a resource pool for IP addresses just for your VXLAN tunnel endpoints, which obviously encapsulate and de-encapsulate in those Ethernet frames or VXLAN frames with the Ethernet frame within it, respectively. But here, again, just for simplicity, I'm just going to use loopbacks, keeping it simple, assign it, and done. That will then update the assignment, and everything is looking good so far. Let me just come back to routing zones. So here I've got to say what the loopback IPs are. So I'm just going to say this is using the loopback IP address. There we go, loopback pool. As you can see, everything is looking great. Loopback here. And layer 3 VNIs. Done. Okay, and that actually just does remind me. I think I might have made a slight, I did make a mistake here because I've assigned the VTEP IPs sorry, the VNIs to layer 3 VNIs. That it's not. This is where human error misconfiguration really comes into it. We're all human, we make mistakes, but you can actually see that Apstra has created the tenant 1, tenant 2, tenant 3 for VNI ID 5041, 5042, 5040 respectively, but you can actually see I want these VNIs. But for now, I'll leave it. I'll change it in a few minutes. It's really just a case of going into each back into each one and saying, yeah, I want you to use 5010, 5020, 5030 for the different tenants themselves. We're all human, we make mistakes. It's easily corrected. So first, let's actually commit this configuration. So if I actually go into committed right now, you can see there's no built errors, there's no warnings. Great. So I can actually commit this configuration. I could just say this is initial configuration with virtual networks and routing zones. And this is important for what you'll see in the next session itself. So if I commit this, this is then going to not only save this configuration, but it's then going to deploy that configuration onto the network itself. And obviously this is going to take 1 or 2 minutes. It's got to come down and it's got to go onto the devices themselves. We can see now on the dashboard, we're starting to get some anomalies. That's really, there's some cabling issues, there's some BGP, but these will resolve over time. BGP does take 90 seconds or so to actually resolve, but these will resolve themselves. As you can see, it's getting less and less. But if I actually go on to back to my lab now and just click on any device, it's just do leaf 1 admin and admin, disable it and show run. You can actually see now all that configuration which I've just configured on Apstra has been pushed down onto the device itself. Now, this is important because you're taking away all the time necessarily that's needed to do the CLI configuration, the expertise that's needed therein. I made a mistake on the Apstra, but that's easily corrected. And once I correct it, the leaves, the spines will be updated respectively. But as you can see, the cabling issues have all gone, but the BGP anomalies remain. That will resolve again. But this really does show how fast and easy Apstra is to use. Obviously, there's not one solution with just one button, and you push a button and everything is deployed within a matter of seconds. You've obviously still got to stage a configuration and say who is what the IP addresses, ASNs, etc. But once you've actually done that, the final step is actually to then say, well, how is this all connected together? So if I actually add a template, here is where you actually say, well, how is tenant 1 connected? So this is tenant 1's connectivity template, and you can use primitives, which are sort of like pre-configured, pre-saved configuration templates. Now this is each leaf is accepting untagged traffic from each of these servers. So untagged, there's no static routes, there's no BGP peering, etc. You can see that there's no border leaf here. So here I'm just going to use a virtual network single. You can create more static route, custom static routes, BGP peering, routing policies, etc. So now if I go back to parameters and I can say for the virtual network, I want this to be tenant 1 virtual network and untagged. Let's create another. Tenant 2, connectivity template, primitives and virtual network again. This is tenant 2. I will obviously change the VNI, untagged. And finally, tenant 3, connectivity template using a virtual network VLAN, single, untagged. And create. And that's it. That's now done. So there's some more configurations that need to be pushed down. So if I actually go into uncommitted, so this is uncommitted configurations, you can actually see that it's going to add these connectivity templates to the existing configuration. If we go to full nodes difference, you can see the difference between what's currently deployed and what will be deployed, but that will take take a while to build, so I'm not going to do that. There's no errors and there's no warnings, so everything is looking great. Commit this changes and let's do configuration 2 with connectivity templates. Commit. And this is great because, again, you'll see on the next session is where I can use time forage if a user does create a misconfiguration or wants to revert back to a particular software or hardware load. Many reasons why you'd want to use the time voyager. Okay, and that's it. That's really how we have deployed our data center. So last session we built this data center, and in this session we have deployed all of the information onto the data center itself. So if I go back to Leaf 1 now and do show run again, it's done all that configuration for me. And you also see somewhere in here, obviously there's a lot of information that Apstra's done for me seamlessly. Here you go, here you can see the configuration here. And note that the gateways themselves, Apstra has just done all that hard work for me in a matter of minutes. Okay, so let's come back to my PowerPoint. So that was, as I said, we've designed our data center, we've built and deployed it now. The ASN pools, the IP addresses, the fabrics, the routing zones, the virtual networks, the connectivity. And on the next session, we are going to be focusing on day 2 operations, i.e. operating and assuring that that data center that we've designed and built and deployed is operating, is connected, and is performing the way it should be, i.e. is it meeting your intent? And this is how we've got that closed loop validation, because we are designing, validating, building and deploying, validating, operating and validating. And if at any point the intent deviates away from what your intention is, i.e. your intent, then Apstra makes you aware of that. And you'll see a lot of this on the next session itself. So to close off, if you have any questions, please email again the team at sales@kubus.com, and they'll be more than happy to take any questions that you might have. But other than that, I thank you very much for your time. Thank you for listening, and I look forward to welcoming you and seeing you on the next and final installment of Juniper's Apstra solution. Thanks very much for watching, and goodbye.